In this video, all students will be able to solve a system of equations, again using substitution, but day 2, because variables are going to be on one side this time. So, you know that this is a system because it has two equations. You know that you should use substitution because you have a y right here by itself. So, y equals 2x plus 3. What does y equal? 2x plus 3. What does y equal? 2x plus 3. What does y equal? 2x plus 3. You're right. So wherever we see a y, like right there, what can we put in there instead? 2x plus 3. Perfect. We're going to substitute in the 2x plus 3 right there. Okay, so I get this first 2x, then I get the substitution 2x plus 3, and then I'm going to finish up that equation, equals 7. So take a moment. I want to make sure you understood that step. Right down here, I had y equals 2x plus 3. Right here, I had a y. So, what am I going to replace it with? 2x plus 3, which is what I did right here. So you see how let me see if I can block this for a second so you can see it better. So you see how these are the same thing, but where the y was, I put in 2x plus 3? Does everyone see that? I hope so. All right, let's go ahead and solve it out now. So, on this side I have 2x plus 2x, which is 4x, minus the 3 over. 4x equals, on this side I get 4. Divide by 4s, and x equals 1. Awesome. That's half of my answer. Go ahead and pause the video now if you want to, catch up on the first half. Otherwise, I'm going to keep going. So now I know that x equals 1. So I can take either of my two equations, either one, and I'm going to plug in 1 for x. I'm going to take this one over. I'm going to plug in 1 for x. 2 times 1 is 2, plus 3 is 5. So these two lines cross at 1, 5. You might be wondering, what would it look like if I had plugged it in to the other one? You're probably not wondering that, but oh well, we're going to do it anyways. Let's try it on the other one. So if I put in the 1 for x, two times 1 is 2, minus the 2 over, and you get y equals 5, right? So either one, as long as you plug it back in, same thing. Go ahead and pause this video and get caught up. All right, example number 2. I know that this is a system because it has two equations, right? I know I should use substitution because I have y right here that's isolated. I have y by itself. Cool. I want to make sure you understand this is a system that we can solve using substitution because we have a y by itself. Speaking of which, what does y equal? Y equals 3x plus 7. What does y equal? 3x plus 7. What does y equal? 3x plus 7. What does y equal? 3x plus 7. So wherever I see a y, like right here, I can put in 3x plus 7 right there. So let's see what that looks like. I have this x plus, now I have two y's. So when I substitute this in, I'm actually going to keep 2 times, and then I'll put in the 3x plus 7. So I want to make sure everyone understands what I just did. Let me see if I can make this happen. in this equation, I put in 3x plus 7 where y used to be. I substituted it. The thing that was different about this problem, however, is that there was a 2y here, so when I substitute in, I had to keep the idea of multiply, so I had to use the parentheses. If that makes no sense to you, or if you need me to explain that to you in person, go ahead and put a star next to this step. All right. So let's continue. We got the 3x plus 7 substituted in. You'll also notice that I have no more y's left, which is good. That means I can solve. 6x plus 14. Combine like terms. And I get x equals 1. Again, that's weird. Coincidence. X equals 1. Now, I have to use that 1 for x, and I have to plug it back into one of these two top equations. Does it matter which one I plug in for? No. I could plug in for this one, or I could plug in for this one. I have showed you multiple times that you will get the same answer no matter what. So I'm going to plug in 1 for x. I did the top equation. So y equals 10. These lines cross at 1, 10. Go ahead and pause, get caught up if you need to. We're only going to do one more example before you try it on your own. Number 3, find the solution to the system. What does y equal in this problem? Y equals x plus 2. What does y equal? X plus 2. What does y equal? X plus 2. What does y equal? X plus 2. So wherever I see a y, what can I put there instead? I can put in x plus 2. So I'm going to go ahead and start this off. 2x, and then I have a minus y, so that's going to be negative 1 times. Now I'll go ahead and substitute that in. Okay, I like what we started doing earlier, where I covered some of them up to make sure you really understood. So I'm going to cover this one up again. All right, so where I had a y before is actually a negative y. I put in the negative 1, and I substituted in x plus 2, right? X plus 2. If you are having a difficulty with that first step, please put a star or make a note of it on your paper so you can ask me about it, okay? All right, so we got it all substituted in. So I have 2x minus x minus 2 equals 10. 2x minus x is just x. Plus 2 makes 12. So x is going to be 12. And then go ahead and pause it now if you want to get caught up. Now you're going to have to take this 12 and you have to plug it back in for x, either on the first one or on the second one. I think the first one is easier in this case because I'm just going to put it like this, and all I got to do is add 2 to it. So y will be 14. So these two lines cross at 12, 14. Also, take notice that if you wanted to graph this, you would need a very large graph. So substitution definitely has its advantages. All right, honey bunnies, do your gate check.